Okay, lesson 1A, we are going to be talking about converting verbal expressions into algebraic equations or expressions. And then we're going to talk about doing that the opposite way, meaning that you guys are going to be given some sort of algebraic expression or sentence, and you guys are going to have to put it in words. Okay, so this is kind of talking about dealing with your word problems, and you guys are trying to set up equations so that you can solve them. I threw in a couple words there that I just want to talk about. One of them is expressions, and the other one is equations. Okay, just to kind of define the difference between those two, there's really no difference other than one important aspect. Your equations have equal signs. I started writing equations, I'm sorry. Have equal signs. Okay? Expressions are the exact same thing, but your expressions don't have equal signs. No equals. Okay? So if I have 2x plus 3, that is an expression. If I have 2x plus 3 equals 5, that's an equation. So this here right here is an example of an equation. Okay? If I take away the blue part and I just look at the part that is in red, that is an expression. Okay? So we are going to be writing expressions and we're going to be writing equations. All right, so let's go ahead and get started. First thing when you guys are rolling through this is there are going to be some keywords that associate. Okay, and they will help us if we can find these key words when we're reading through that word problem. That will help us to determine if we need to have an addition sign, if we need to have a subtraction sign, multiplication, division, or equals. Okay, so the first thing that I want you guys to do is I want you guys to pause this video. Okay, hit pause, and I want you to brainstorm. What are some words that tell you to add? What are some words that tell you to subtract? So pause the video and write those down. Okay, hopefully you guys have paused the video and wrote those down for us. I wanted you guys to kind of get your own brainstorming going down, see what you guys thought of. When I brainstormed for this, so for addition, I feel like one that's kind of obvious is plus. Okay, total usually means addition. Increasing, if you are talking about increasing or they're increased by, okay, that would be something that would mean addition. Altogether. Altogether is a big one. One that I think people forget about, sum. Okay, sum would be an example of one for addition. Okay, now there are other words that are there for addition. More, in all, added to, together. We put all together up there. Any of those words, okay, would be included for our addition. And there are probably many more. If you guys are thinking of more and you're not sure if it's addition, send me an email. Or you can jot it off to the side and then ask me when you get to see me. Okay? Subtraction keywords. Less. Okay? Or less than. Minus. I feel like minus is one that people say a lot. How much more? How much more? That one all together. That one has the word more, which makes people think that it's addition. But if you're asking somebody how much more of something they have, you take the total minus whatever it is. Okay? And then another good one for this one would be difference. Okay, I put sum and difference down. Remember, difference, that is the answer to a subtraction problem. So anytime you see difference, that means minus. Sum, hopefully you guys remember the sum, that is the answer to an addition problem. Okay? Multiplication keywords. I feel like a lot of you guys probably wrote down times. Okay? If you see something like multiplied. Okay? Those could all be ones there. We've been talking about answers to subtraction, answer to addition. What's the answer to a multiplication problem? Well, that would be the product. Okay? Another one that I like for multiplication, of. Typically when you see of tells you that it is going to be multiplied. Okay? Twice, okay, that means specifically times 2, doubled, times 2, tripled, times 3. If you're talking about area or volume, you're probably going to need to multiply because we have to multiply to find our area or our volume. Okay, division. Division, obviously you could put divided. That would be one. The answer to a division problem would be your quotient, if you hear somebody talking about a quotient. Okay, ratio. Ratio would be an example of division. How many times? And when I'm saying how many times, I'm talking about how many times does something go into it. Okay, so if you have 6, how many times does 2 go into 6? Well, that's going to be division, 6 divided by 2. Okay, and then another one that I think a lot of us don't realize says division would be per. Okay, when we're talking about miles per hour, we're taking miles divided by hours. That's what that per tells us there. Okay, and then the last one, equals. Okay, well, obviously you could see it written as something equals. Okay, you could see they might be talking about the result is. Okay, so if you're multiplying some things together, the result is 5. So that would equal 5. And then not just the result is, you could just simply see the word is, or you could see that something, or it wouldn't be something, it'd have to be a plural. That's some English stuff there. But is or are would tell us that it is going to equal. Okay, again, there are a lot of other words. If you guys have some other words that you think could go in there, you can share them in class, or if we're not in class, you could just simply email them to me and ask if they would fit. Okay, but we've got a good list of words now that we should be looking for, some key words. Okay, so we're going to start out here. It says, write an algebraic expression to represent the verbal expression of 6 more than a number. 6 more than a number. Okay, 6 more than a number. When you see a word problem, the first thing that you guys need to do is you need to underline the important pieces of information. The first important piece that I see would be 6. That's probably going to matter. The next thing that I see is I see more than. Okay? And then the last thing that I see up there is a number. Now, we didn't really talk about a number, right? Now, if they're talking about a number and they are not specific about this number, that is where we are going to plug in our variable. Okay? Now, what are variables? Remember, your variables are going to be numbers. Okay? But they aren't assigned a value yet. So that value can change. It can vary. So when we are talking about variables, we are going to use our letters to represent variables. Common letters that you can use. X. Another common letter you could use would be N. Okay, you could use Y, you could use A, you could use B, you can use C. It does not matter what letter you use. Okay, you just need to use some letter, and that letter is going to be a placeholder until we know what number needs to be plugged in there. Okay, so we've got a number, we've got a variable. So it looks like the number we are going to use is going to be X. Our variable is going to be X. Okay, so a number, the specific one we're going to use is going to be X. They gave us a 6. So we're going to have a 6 and an X. So what does more than tell us to do? Okay, now, some of you guys might see more than and be like, oh yeah, last slide, Mr. Schieber said that how much more than told us to subtract. But this is just more than. If this said how much more than, then yes, we would subtract. But when it's just talking about more than, that's telling us that we are going to be adding. So our answer for this question would be 6 plus X or X plus 6. Okay, so the answer for this one would be B. All right, next example then. Okay, write an algebraic expression to represent the verbal expression 2 less than the cube of a number. 2 less than the cube of a number. Pause the video, and I want you guys to underline the important information. Pause the video, underline the important information. Okay, hopefully you guys have that video paused, underlining important stuff. 2, okay, less than, and then we have the cube. Okay, now that's something new, we didn't talk about that. And we've got a number. Okay, all right, so obviously the 2 is just going to tell us it's a 2. The number That's where we've got our variable, so we can pick a variable. It looks like based on the answers they've used x. You can use any variable that you want. Okay, the cube. Okay, remember cubed, squared, all of those numbers. If I have something squared, there's a little 2 up top. When I have something when I have something cubed, that's when you're going to have a little 3. Okay, so x cubed, that would be the cube of a number. All right. And the last thing, less than. What does less than tell us to do? Some of you guys are going to say that or that. Okay? That's not what less than tells us to do. We need an operation when we're talking about less than. And less than tells us that we are going to subtract. Okay? So, it's not B. It's not D. We're definitely going to subtract. Okay? And we have x cubed minus 2. X cubed minus 2. So A would be our answer there. Okay? Now, I want you guys to try these next two on your own. You have 7 less than a number. Okay? Try that one on your own. You've also got, right, an algebraic expression to represent the verbal expression. The square of a number is decreased by the product of 5 and the number. That is a lot on that one, but I'm going to have you guys try those two on your own. Start out by underlining the important information. Okay, so the first part, 7 less than a number. We kind of just went over this. This one here is 7. Less than we know is subtraction and then a number. Okay, we get to pick our variable. This time let's use n. Okay, because it doesn't matter what your variable is. Now, 7 minus n is not the correct answer. The correct answer would be n minus 7. N minus 7. This less than symbol here, when I taught this, I used to teach middle school, they called this a turnaround phrase. Anytime you see less than, the order here flips. Okay, and the reason is, let's say you had, say it wasn't a number, say it was 7 less than 11. Okay, 7, what is 7 less than 11? The answer is not -4, the answer is 4. Because 7 less than 11 means 11 minus 7. That tells us 4. Okay, all right, next one, the long one. There we go. Okay, underline important information. Square of a number. Okay, decreased by. Decreased by, what does that mean? The product of 5 and the number. Okay, now, they're talking about the same number there. Of a number and the number. They're talking about the same number there. So what variable do we want to use? Let's use n again. I kind of like n. Okay, so both of those here, those mean n. Square. What does the square mean? Well, the square means that little 2. So that's an n squared there. Okay? Product. What does the product mean? Product means multiplication. So multiply. Okay? And then we have the product of 5 and n. So it's the product of these two numbers. Okay? And then the only other part we haven't talked about yet would be decrease by. Well, decrease by would be a good one for subtraction. Minus sign. Okay? All right. So we've got the square of a number, n squared, decreased by, minus, the product of 5 and the number. Okay? So that we could write as 5n. Because if you squeeze two numbers together, remember that means multiplication. You could also write with a little dot there, 5 times n. Probably don't want to write the x because we are using variables at this point. Okay? All right, the last thing is you have a verbal sentence, okay, and we want to turn that in. I think this is way easier to do than the other option because you just kind of read. 6 is equal to -5 added to x. Okay? You could also do 6 is equal to the sum of 5 and x. Okay? That would work as well. There's a lot of different options that you can do on that. Okay? Go ahead and pause the video. Try this next one on your own. Pause the video. Okay, I'm running out of time, so you guys are going to want to pause the video here. I gave you guys a couple of examples for what this could be. Okay, sorry I ran out.